Thank you. It's really my pleasure and honor to be here first time, represent our company ICCPP Group, which is one of the parent company of WUPO, a famous open system provider. So this time we'll also have the honor to discuss a little bit about tobacco harm reduction. And the speaker is Milos Wang, who is our doctor and the chief atomization scientist. And at the same time, he is also the head of our innovation research institute. So because there's some issue of his travel visa to here, it's delayed, so that's why he can't be here physically. And fortunately, we have a plan B, contingency plan, and we have a video recorded for the presentation of 10 minutes. And we can see from the videos and how we can do for the vaping products to be more like harm reduction and how our product can be more like environmental sustainable perspective. And we can start the video, and after the video, if you have any questions, we'd like to answer. Thank you.
Hello everyone, this is Milos Wang from ICCPP. It's my pleasure to discuss tobacco harm reduction with so many professionals. Due to some reasons, I can't personally come to the venue. It's really a pity. ICCPP Group is a technology-based company driven by technology and talent as its core. Our concepts are harm reduction, safety, and environmental protection. We have established an advanced lab devoted to pursue the highest industry standards and the latest technological achievements. Under the advanced lab, we have established an innovation research institute for researching atomization mechanisms and the new atomization technologies, a new material research institute for developing new atomizing materials, a life science research institute focused on the study of new liquid and the toxicity of aerosols, and a research institute of electronic chips for studying the function of chips and the precipitation of human-computer interaction technology. We invest an average of 10% in R&D every year. Thus, we created a comprehensive research system that concerns about both basic research and technological transformation. Next, I will share some of our achievements. As known, electronic cigarette performs well in harm reduction. Compared to traditional tobacco, a report published by the BLA shows that the prevalence of laryngeal cancer and vocal cord cancer is relatively low among people who use electronic cigarette. The Roy Castro Lung Cancer Foundation believes that the use of electronic cigarette can effectively reduce the harmful elements inhaled by smokers and may reduce the risk of lung cancer. So, we are thinking about why electronic cigarette can reduce harm. We believe that the temperature of atomization plays a crucial role. Electronic cigarette can be divided into HMB and vaping. The heating temperature of HMB is usually below 350 degrees, and the heating temperature of vaping products is lower. The heating temperature of these two products is much lower than that of traditional cigarettes, but they haven't yet achieved totally harmless. For example, while the harmful elements of vaping are reduced by more than 95% compared with traditional cigarettes, this is still 0.68 to 5 mg per still formaldehyde in the aerosols, which is still higher than 0.5 mg per still specified in the safety standard. Therefore, in order to further reduce harm, it's necessary to further reduce the heating temperature. At present, we have achieved two methods to control the heating temperature. The first method is to prevent dry burning during use. You should also be aware that the release of aldehydes will increase when the liquid is almost used up. This is due to the rapid increase in temperature and the dry burning when the liquid is depleted. In order to prevent the possibility of occasional cold-sticking issues and the dry burning problems caused by the rapid depletion of liquid during use, we have developed our own anti-dry burning technology. In this technology, we control the output of the battery through an electronic program to ensure that the heating temperature doesn't exceed the limit. In other words, as long as an upward trend in temperature is detected, the output power of the battery will decrease. It is compatible with both flute and tobacco flavors. Secondly, we also try to reduce the boiling temperature. For vaping products, the process of aerosol generation is divided into two steps: the surface boiling of the core and the mixed condensation of hot vapor and cold air. Research has shown that as the oil conductivity of ceramicals changes, the thickness of the liquid film on the heating surface will change, and the surface boiling of ceramicals may have two boiling states: pore boiling and thin film boiling. We found that pore boiling poses a risk of oil splash, so we need to control the atomization in a thin film boiling state. As shown in the red chart, we test the pore temperature covers of ceramicals with different processes. It's not difficult to see that under the same pore, the boiling temperature will also decrease when the ceramical process decreases at the same time. If the process is too large, the boiling state will turn to the pore boiling state, which will be harmful to product performance. In addition, there are data indicating that for the liquid with Pg to Vg equals 1 to 1, when the reactor temperature reaches 215 centigrade, formaldehyde and acetaldehyde begin to increase significantly. And when the temperature exceeds 270 centigrade, acrolein will increase greatly. And at the same temperature, Vg produce much higher levels of aldehydes than Pg, so we are considering using other solvents to replace Pg or Vg. Therefore, we studied water-based liquid. Left chart shows the boiling temperature of water-based oil with different contents. As the water content increases, there is no significant change in boiling temperature. However, the pore temperature covers of different proportions of liquid shown in the red figure show that as the water content increases, the pore range in the film boiling state significantly increases. This means that an increase in water content can effectively improve the adaptability of the products and reduce the risk of dry boiling. ICCPP is also a highly socially responsible company. We not only focused on atomization safety, we also on environmental friendly issues. We have noticed the public concern about the pollution caused by the popular disposable e-cigarettes. So this year, on the basis of integrating the first application results of degradable materials in 2020 and combining the prospective study of EU On the recycle of e-cigarette, we launched a full range of removable and degradable e-cigarette cycler. You can see the new product we are about to launch in my hand. Cycler can not only meet all users' comprehensive disassembly needs, easy to removable for adult vapors, with a child lock to prevent children's use, but also have low lead inside and wide leads, which relaxed the fully disassembly and suitable recycling of all electronic cigarettes, accessories such as batteries, electronic components, and inadequate charcoal, and so on, combined with the application of new PLA degradable materials, which making the shell fully degradable in the soil within 3 to 6 months. Cycler greatly improves the environmental friendliness of electronic materials and achieves a truly zero harm oriented and eco-friendly. In the future, we will continue to take the cycler products as the origin, take the user as the center, continue to innovate the principle and structural application of electronic administration technology, combining our own and the industry's in-depth research on the toxicology, administration mechanism, and the user's needs of e-cigarettes. Create more new tobacco products that satisfy users and reassure the public. Continue to promote the sustainable development of our own and the industry, and create a better future for the electronic administration industry. Thanks. That's what I share.
Thank you very much. Thank you very much, Miles. And William, welcome back to the stage. So I'll ask a question, but forgive me a general question. But I don't know what percentage of the world's e-cigarettes are now made in China. Are we getting closer, and hearing the stuff that you're doing, are we getting closer to a stage where we can, every e-cigarette that's made is going to be at least 95% safer than a cigarette? Or is that still a bit of a pipe dream?
I think, yes, you're right. The majority of the e-vaping products are produced in China, especially in the Guangdong province near Shenzhen. And it's true that we have a brand portfolio of the vaping products, and which is 95% of less harmful than the combustible ones. And we do think that we still have something to do, how to further reduce the harmful of the e-vaping products, especially just like our Dr. Millis Wang demonstrated, because we are trying to control the temperature of atomization, and which is a key to reduce the release of some aldehydes and heavy metals. The lower the temperature for atomization, the less harmfulness of release, for sure. And just like the anti-dry burning technology and our water-based e-liquid technology can be adaptable to a lot of different flavors, not only for tobacco, but also for some fruity flavors. And I think this is a long journey to see how we can move forward for the vaping business. And at the same time, we also mentioned that the disposables still have the environmental protection problem, and we are trying to have this detachable one, which can be easily recycled and to be even detached by the consumers by themselves. So this is two ways. One way is to control the HPHC release from the current technology. And the second way is how we can to be sustainable for the vaping business. Just apart from nicotine pouch, apart from heat bun, vaping business is still a very popular category for the reduced risk product at the time being. So we do think that we still have a long way to go. Thank you.
Thank you. And I did like your team strapline, the innovation shifts the future. You're a man after my own heart. Sorry, I can't see any hand. I can see a hand right over there in the distance. Is there a microphone near you?
Thank you. Based on the expertise you have on the device itself, why is there a poor literature which comes from Chinese companies? Because as you've seen, most of the tobacco companies publish data on their product. And I think what's missed significantly in the literature is some information on the device itself, and which is the expertise you have.
So, excuse me, so you want to, we highlight on the specification of the device, is that right?
Yes, for example, why the data that was shown in the presentation are not published somewhere? Because the regulators need the information on how the device operates, on how the device can be regulated in terms of temperature, and also on the risk of which is linked to the boiling process. And I think this information are really missing in the literature. Thank you.
Yes, we do have some information on the specifications according to different devices. And some are disposable ones, some are closed pole system. And because this is just for the technology meeting, so that's why we are only focused on how we can do to reduce the harmful, potential harmful components to be released. And if you want to know more about our specification, I think because different countries have different regulations, and we can just comply with all of the FDA's and the TBD's regulations on the products. Yeah.
Just to go slightly deeper, and I think it will be on the presentation of my colleague Roberto Aranzuzman. You will see that we are trying to evaluate the consistency of the literature based on the device characteristic and on how they are normally used. And there is a gap between how most of the laboratories consider the product and on how they are really used. And this gap only comes from the lack of knowledge on the physics behind the device itself, which is, in my sense, the expertise that you might have in your labs because you are the device manufacturer.
Yes, yes, you're right.
Thank you very much, and I think we should move. Thank you very much, William.
Thank you.